Today we're going to be discussing the phase 2 of our presentation on the Platinum panel meters and controllers. Phase 1, we showed you an introduction to the product and basically its functionality and advantages. Today we're going to show you some of the software features involved, including data logging and configuration. As I mentioned, all Platinum units will have a standard USB port, and on that USB port you'll be able to upload and download firmware, move configuration files in and out of the unit from software or from one unit to another, putting the configuration on a thumb drive or firmware back and forth from a thumb drive from our website. I showed you those links earlier. So on this PC, you'll see on the desktop, there's a Platinum icon. This was loaded off of our website free of charge. And if we open that, you'll see it brings up the configuration software. The first tab or the first box that comes up is the connection box. So there's a little icon here called Force Connect or Force Channel. If that's clicked and we pick the proper COM port and click Connect, through the USB port, it's going to connect to the unit. And here you see we have a live unit through our demo box, and here we see it's showing temperature in centigrade. And this is basically a mirror image of the face of the unit, which we'll show you later. So here on the screen, this is the config software. Let's open it up to full screen. And on the config software running live, you can see your two set points, and you can see what mode the controller's in. It's basically running right now. We can also put it in standby or stop. This would turn off the outputs. Same with idle, which would stop like a ramp and soak. And same for pause. We also store a peak and a valley. And these are the highest and lowest readings since your reset. And then you can also clear any latched alarms. These are the annunciators that tell you when a particular output is enabled and whether you're in Fahrenheit or centigrade. Current mode is running on this demo unit, and you see we're controlling it around a little bit elevated above room temperature, which we'll get to later in a physical demonstration. The important thing of the configuration software is just the word implies, configuration. So just like the menu items through the front panel push buttons, you'll see these building blocks. These building blocks are basically the inputs and the outputs. So as I mentioned before in the functional description, the process inputs block, this is where you pick either your thermocouple type or whether you have RTD, which we went over, or whether you have thermistors, or the process variables, which is either current or voltage. So you can pick anything you want here. If you do happen to pick process, that also opens up scaling. Scaling, of course, would be converting your low and high input signal into a low and a high display reading. For example, if you're doing pressure with a pressure transducer and you're doing a 4 to 20 milliamp input, say from a PX309, and you want that to read at 4 milliamps, you want that to read 0 pounds, and at 20 milliamps, you want that to read 200 pounds, and you just put that data in here, and now you're drawing a linear line. As your input signal changes low to high, your reading display changes low to high. This is typical what's called process scaling. So we'll go back to thermocouple on this because that's what we have it set for. And we'll close that out. The next building block, we've got auxiliary input. Well, I didn't speak much of this, but this was what we call the remote set point. And just like the display scaling, you can pick, once you pick whatever your signal is, 4 to 20, 0 to 20, 10 volts, whatever, 0 to 1 volt, you can also choose what that scaling is on the analog input for the remote set point. So let's say you want 4 to 20 milliamps, would change your set point from 0 to 100 degrees. That's basically what you put in here, and as that 4 to 20 comes in on its unique set of pins, it would alter your set point accordingly. Annunciators, as I mentioned, these are the little buttons here on the left, these little lights, little LEDs, and on this particular annunciator, you can choose what you want those lights to be. They're not fixed. So the very first LED can be either one of two alarms. It can be any one of your outputs that you may have in the unit. It can also light when you're doing a ramp or a soak operation. And same for output or annunciator number 2. Set points, that's just what the name implies for your outputs. And you can assign any output to any set point. You don't have to have output 1 be set point 1 and output 2 to be set point 2. You can assign output 3 to be set point 1, whatever you want to do. Now, set point 2 can have its own unique number like set point 1, or you can have it a deviation from set point 1. So let's say I make my set point 100 degrees on set point 1, and let's say my output 2 is, say, like an over temp alarm. 10 degrees higher. Well, rather than put in a fixed number of 110, I can just put this in deviation mode and basically put in 10 degrees so that any change to this set point would add this amount to the second set point. That's called deviation. Also, you can make set point 1 be affected by that remote input instead of that fixed number on the display. The alarms, we have a very functional, elaborate alarm system here. You can basically have it active above, active below. You can have a band when you're inside a low and a high value, or you can have what's called high-low, which is above a high value or lower than a low value. So very flexible. You can even have a high-high alarm, which means in addition to the standard band or high-low, you can have an extra high alarm, say like an emergency fail-safe condition, well above a set point in case of fire danger, something along those lines. You can set it for deviation, just like the controlling set points. And then here's where you actually enter in your actual set point values. You can also have it delay. You can have it delayed on, you can have it immediately upon a power on, or you have to actually cross the set point for it to happen. You can delay it, and you can have an on value delay and an off value delay. So that way, let's say you have a spike that isn't really a true process variable, but it would be enough to trip your output or your alarm. You can delay that. So it's really only going to happen if it's truly an event that takes place over a period of time. Latching as well. You can have them latching or unlatching. Latching would mean to set the relay or the output is energized and stays energized even if you fall out of the alarm condition. Digital input is going to be a remote input where basically you can bring in a contact closure or a signal to make it do different things. This is going to be a functional building block. Later on, we're going to introduce many different things you can bring in on that digital input. Right now, you can use it to trip a latched alarm or to reset a tare value and things of that nature. Ramp and soak we're going to get to in a minute in more detail, but as I mentioned during the functional block, there's 99 profiles you can do. And basically you can ramp up to a certain set point, hold there for a period of time, and then move on to the second profile. And this can be a forward direction or a backward direction. And you can keep doing this up and down, left and right to your heart's content. Very flexible and powerful algorithm. And of course the outputs. The outputs are where you, as I mentioned in the functional block, the unit knows through firmware what physical outputs are in the product. It knows whether it's a mechanical relay. In this particular example of our demo unit, our first output is a mechanical relay, a single pole, single throw. We also have a DC pulse and then a second DC pulse. So you can assign these to any set point, as you can see, and you can put in different dead bands. For example, this relay is set for an alarm condition, and it shows you the dead band and the cycle time, and then the all the functionality for that relay. This second output is a DC pulse, which is driving an electric heater through an external SSR. And then we have an output 3, which is driving something else. But they're very flexible. This can all be done through the configuration software or through the front panel push buttons. We'll go into more on this in a second. As I mentioned, excitation, very powerful in this unit. It is standard. It is not an option. And you can have excitation of 5, 10, 12, or 24 volts, all set through software, or you can turn it off. Also on this screen, the reading screen, we put our miscellaneous selections where you can pick your decimal point position, you can pick Fahrenheit or Celsius, and then you can also pick the color of the display. Now remember, this unit has a tricolor display. It has a red, green, or amber for a normal color, and if you want, you don't have to, but if you want, you can change colors from one to another as you cross any of the alarm set points. Those set points can be the controlling set points for your outputs, or they can just be merely color-changing set points not related to your outputs. And there's a time format. This is for your ramp and soak algorithms, where basically you can do hours and minutes or minutes and seconds. There's also some other miscellaneous things in here, such as, let's say, when you first power on the controller, do you want it to wait for an operator interaction on the push button, or do you want it to go immediately to a process variable and do your controlling? There's also set point limitations. This would be important if you want your operators not to be able to enter in wild set points that could cause damage or damage products. So that's our miscellaneous tab. Safety is another tab where you can, well, that's still under the miscellaneous. That's, for example, a loop break detect on your output. That if you enable that, it's going to give you a warning indication and turn off your output. And open circuit detection as well. The display mode, as I mentioned, Fahrenheit or centigrade on the temperature, any decimal point position, and the color. There's also a graphing function on here. Now, a future version of this software will be doing data logging. I'm going to be showing you how to data log right now with this product, but a future version of this is going to be data logging. In the meantime, you can do charting and graphing. And as I mentioned, this product is connected to one of our demo boxes, and one of my colleagues is going to demonstrate that to you in a second, and go a little bit more into detail as far as the charting. While we're still here, let's go in. I mentioned very briefly the data logging. If you have the Ethernet option, we have a free software used on any of our products that have Ethernet capability, and that's called iLog. So let's go ahead and load iLog, and while the configuration software is running, you can also run this in the background. So there's our iLog software. I'm bringing it up now. It's simply a macro that rides on top of Excel. So as you can see, we've enabled scripts, and basically you go into options, you put in the IP address of your unit, as long as it's on the same subnet or node as your PC's IP address on that portion of the network, put in the port, pick the product. As I mentioned, iLog is used on a variety of products. We're calling this, in lieu of a Platinum update, we're calling it the I-Series because it responds to the same command format. Pick how often you want it to sample. Let's put in something like 2 seconds. Click OK, and we click Start Logging. And here we see it gives you a timestamp, a date stamp, and the process variable in this column here. This is currently a temperature, no errors. So every 2 seconds, I'm getting an Excel spreadsheet row with a process variable. Now, obviously, being Excel at this point, you can merely save the file, transfer it, email it, do whatever you want to do. And I think Excel can hold up to, 65,000 some odd rows before you have to make a new Excel column. This is our data logging software running in the background while our configuration software is running. Now to give a little more demonstration on the configuration software and the functionality of the controlling algorithm, my colleague Karen Yu.